Hi, I'm Mr. Chu and you're welcome to my study room. If today is your first time of visiting this room, then I strongly encourage you to subscribe to my channel, Mr. Chu Study Room, immediately. You like and share the videos as well with your friends. Today's lesson is on indices and specifically the laws of indices. Let's go straight to the lesson. Thank you. So indices are numbers written in the form A exponent B, where the down one, which is the A, is called the base, and the top one, which is the B, is called the exponent, or power, or index. So simply put, the word indices here is just the plural of index here. All right, we go on to the numbers we are going to deal with are going to be in this form: a number with an exponent. We go to the laws now. All right, laws of indices. So the first one, I choose to call it the product law. And this law says that A exponent m times A exponent n equals A exponent m plus n. This is what it means. It means that if you have a number carrying an exponent times the same number, remember A is here, the same A is here. So times the same number carrying an exponent, the answer you will get is the same as you keeping the base and adding the exponent. So for example, 5 exponent 4 times 5 exponent 3 will give us 5 exponent 4 plus 3, which will give us 5 exponent 7. Another example can be, let me make this I. Another example can be m exponent 4 times m squared times m cubed. So this is just going to give us m exponent 4 plus 2 plus 3, which will give us m exponent 9. Let's take one more example, which we'll call I. We have 2x exponent 4 y exponent negative 3, then all of these times 4x exponent negative 2 y exponent 6. This is going to give us here, this is what we are going to do. The numbers will multiply themselves and the variables will also multiply themselves, meaning that like terms, so to speak. So the numbers which are the coefficients will multiply themselves, then the like terms will also multiply themselves. So first of all, 2 times 4 is going to give us 8. Then x exponent 4 times x exponent negative 2 is supposed to give us, according to law 1, is supposed to give us x exponent 4 plus negative 2. Then we go to y exponent negative 3 times y exponent 6. That will be y exponent negative 3 plus 6. Right, then we simplify further to get our 8, which is the coefficient is standing alone. So we write our 8. Then x 4 plus negative 2 is the same as 4 minus 2. So it will give us x exponent 2, which is x squared. Then we come to our y now. Negative 3 plus 6 is the same as 6 minus 3. That will give us 3. So that will give us y cubed. Therefore, the final answer for this multiplication is 8x squared y cubed. Then let's move on quickly to law 2. The second law, I would like to call it the quotient law. Good. So this law says that if we have a exponent m divided by a exponent n, then the answer is supposed to be a exponent m minus n. All right. So the explanation is not too different from the law 1, except that this is a quotient, so division. It says that if you have a base taking an exponent divided by the same base taking another exponent, then the answer you get will be the same as maintaining the base and then subtracting the exponents. We take an example to simplify that. Or the same thing can also be written as, don't forget that the same thing can be a exponent m over a exponent n. It means the same thing. And that is going to give us a exponent m minus n. I just feel like adding that quickly so that in case you see this and not this, you don't get confused. This is the same as this. So each of them have the same answer. So we take an example now. Example. Here we have 5 exponent 9 divided by 5 squared. So this will be equal to 5 exponent 9 minus 2. And that will give us 5 exponent 7. That will give us 5 exponent 7. Then we can take a second example. We have y exponent a over y exponent 5. As this second explanation here gave us, mean that is going to give us y exponent a. Let me write my a word so that it doesn't look like 9. Y exponent a minus 5. And that is just our answer. We go to the third law, law 3. The third law, I choose to call it the index law. So the name of each law is determined by just the way it looks like. For example, the first one, I called it the product law because the numbers are multiplying. So when you are multiplying, multiplication are products. When you are multiplying, you are finding products. And the second one is called quotient because when you are dividing, it means that you are finding quotient. So now we've come to the third one, which is the index law, meaning that it's going to involve index, which we learned earlier that they are the exponent. So that one says that A exponent m or exponent n is equal to A exponent mn. It only means that if you have an index or an indices, a number with an exponent, and together they are carrying another exponent, you have to simply multiply the two exponents. That is what it means. So we take an example. If we have 2 exponent 4 all cubed, our answer is going to be 2 exponent 4 times 3, which will give us 2 exponent 12. The same way, x exponent 4 or exponent 5, that will just give us x exponent 20, because 4 times 5 is 20. So that is the third law. It says that when you have a number with an exponent and both of them or together it is carrying another exponent, then just multiply the two exponents. We go to law 4. Law 4, I will call it index of product of two numbers. Yeah, index of product of two numbers. That one simple. It's so simple. It says that AB, which means A times B. That's why we say product of two numbers. Both together carrying an exponent. This should be the same as A carrying the exponent and then B also carrying the exponent. Or an additional one, A x b y together carrying an exponent n. That answer, it doesn't change. Remember, it is just an upgrade of the third one. So this is carrying an exponent and is together carrying an exponent again. So we are going to get a x n, a exponent x n, then b exponent y n. And the same applies to quotients. So for example, if you have a divided by b all carrying an exponent n, you still get the first one, so the a exponent n over the b also carrying the exponent. So this is how the index of product of two numbers work. Each of the factors in the product will carry the exponent. Let's take some examples. The first example is 4ab all cubed. So you agree with me that from the explanation so far, this is going to mean 4 cubed times a cubed times b cubed. And this is going to give us 4 cubed is 64, a cubed, b cubed. So each of them has taken the cube. All these laws you are learning, you are not just learning them for the sake of it, but you are going to apply them to do other or to solve other questions involving indices. So we have to pay particular attention to these things. Let's take a second example before we move on to the next law. The second example is 2c over d, or exponent 5. And I think you agree with me so far that this will mean 2 exponent 5 times c exponent 5. Then all over d exponent 5. Because of the way the law was explained, especially here. Good. But 2 exponent 5 is a number. So that is going to give us 32. Then c exponent 5 over d exponent 5. So that is where the fourth law will end. Let's go to the fifth one. The fifth one I know is something most of us will know already. That is zero index. Zero index. And it says that a exponent 0 equals 1. And that one is simple, like I said earlier. Most of us know this already. Any number to the power 0 is 1. So for example, our examples, 5 exponent 0 will give us 1. 100 exponent 0 will still give us 1. And any number, it continues. Any number exponent 0 will still give us 1 no matter the size of the number. Then we go to the sixth one. I choose to call the sixth one negative index. This one says that a exponent negative n is the same as 1 over a exponent n, provided a is not equal to 0. So this one says that any number raised to a negative index is equal to the reciprocal of that number raised to the same but positive index. So as you can see, so the exponent here is negative n. It has become the reciprocal, meaning that 1 over the same thing here, but only that this time the exponent is positive and not negative. And that number must not be 0, because any number over 0 is undefined. It doesn't make complete sense. It's undefined. And the other way around is also true. That is, I mean, if you see a exponent n, you can also write it as a exponent negative n. Meaning that if you have 1 over a number carrying an exponent, if you don't want to write it as a fraction, then you can write the denominator alone and negate the exponent. It will still mean that 1 over that. Or I can have 1 over a exponent negative n here. And if I don't want to write it as a fraction, I will negate the negative n. So negative become positive. So my answer now becomes a exponent n. We take some examples on this. Meaning that if we have 1 over 3 squared, that will be the same as 3 exponent what? Negative 2. Very good. 3 exponent in negative 2, because we are making this negative 3 exponent 2 to stand alone, no more as a fraction. So with 3 exponent negative 2, and also 5 exponent negative 3 can be written as 1 over 5 cube if we don't want it to have a negative exponent, then it will be written as 1 over 5 cube. And then maybe we take last example, 1 over 7. What will it be? Good. That will give us 7 exponent negative 1, because the 7 here is having a 1 that is invisible. So when we bring it up to stand on its own, it becomes negative 1, etc. You can continue. It applies to any number at all we are writing, provided that number is not a 0, then it applies to it. All right, then we go to the 7th law. I've just broken down the laws into smaller units so that we can easily pick each of them. And as we go on and use them for subsequent calculations, these laws will become very, very simple and applicable to all of us. So we take the 7th law now. And the 7th law, I choose to call it the negative index of quotient of two numbers. Negative index of quotient of two numbers. And that says that if you have A over B, all exponent negative m, then that will be the same as, we don't want the exponent to be negative, we want the exponent to be positive. So we reciprocate what is in the parentheses, and then the exponent now become positive. So that will be the same as B over A exponent m, now the same exponent, but now it is positive. We take an example. Example 3/5 exponent negative 3. So it will be easier for us to work this when it becomes 5 over 3, 5/3. Then the exponent now becomes positive 3. And then that will give us, remember earlier one of the laws, that will give us 5 cubed over 3 cubed. And then that will give us 125 over 3 squared is also 3 cubed, sorry, is also 27. 125 over 27. And if you want to write it properly as a mixed fraction, that will give us 4 whole number 17 over 27. All right, let's take the next law, which will probably be the last one for this lesson. So the 8th one, and that one I call it the fractional index. The fractional index. So just as the name suggests, it means that the exponent is going to be a fraction. So in general, A exponent m over n means we are taking the nth root of A exponent m, or some people write it this way: the nth root of A or exponent m. It's the same thing. It's the same thing. So we take some example to see if we have A exponent 1/2. This means that the number that is our n is 2 and our m is 1. So that is going to give us the square root of A, because this one is 2, but square root we don't write. If you write a 2 in it, it will still give us the answer as if we don't write a 2. So mostly the square root, we don't write the 2 in it. That's why there is 2 here, but the 2 didn't appear here. But assuming we are taking the cube root now, it will appear. Assuming we are taking the cube root now, it will appear, meaning that if we have, maybe let me even increase more, not only 1, but let's say A exponent 2 over 3, then that is now going to give us, so now here our n is cube, so it will be cube root of A, then all squared. So this is our m is here. This will always, so your n, your denominator is always what will be, it will be the root you take, and the numerator will be the exponent of the A. Let's take further examples. So that means with numbers now, that means that if we have 81 exponent 1/2, this will be the same as square root of 81, and that will give us 9, because square root of 81 is 9, which if you want to break it down properly, we are going to have 81 is 9 squared, so 9 squared, and the whole of this 9 squared is having an exponent of 1/2, which we did earlier, meaning that this will be 9 squared times the 1/2. So this one will cancel this, and it will give us our 9, which is the same as this 9 we got here. So technically that is what it means. Then we take another example, example 2. We are taking 121 exponent 1/2. We are taking 121 exponent 1/2, and again that one will just give us square root of 121, which is the same as 11. Then we can have 16 exponent 1/4. So again, from the explanation I gave earlier, it means that this 4 is going to be in the root. So the 4th root of 16 exponent 1, but we can choose not to write a 1 because it doesn't add anything to the thing, and the answer is 2. We take the last example. 27 exponent to test, and that will give us, so you see here again our n is 3, so that means that will give us cube root of 27. Then let us not forget our m, which is 2, so all squared, and that will give us cube root of 27 is 3, then the square is here, don't forget, so 3 squared, and that will give us 9. So there you have it, 8 simple laws of indices, which we can quickly go through. The first one, we did a product law, which says that when you multiply two numbers with the same base, you multiply two numbers with the same base, you just have to add the exponent to give you the answer. And we took examples. And the second one is a quotient law, which says that when you divide two numbers with the same base, you just subtract the exponent. And then the next one, the index law, which says that when you have a number with an index, and that number is also, and together they are carrying another index, you just have to multiply the indices. And then the fourth one, which is the index or product of numbers, saying that when you have two numbers multiplying, not only that, even if they are dividing and together they are carrying an exponent, each of them automatically carries the exponent. Then we went to the fifth one, which is the zero index, a very common one, of course, that any number exponent 0 is 1. So in the subsequent lessons, anytime we are calculating an index is 0 or an exponent is 0, we will not write that, we will write 1 for it. So keep note of that. Then we went to negative index. The negative index is saying that any number raised to a negative index is equal to the reciprocal of the number now with the same index but being positive. And the other way around works means that if you have 1 over a number carrying an exponent, instead of writing it as a fraction, you can write the number alone and then negating the exponent you had for the denominator, and then it will work. Then we went to a few more ones, which is the negative index of the quotient of two numbers, meaning that when you have two numbers dividing, one dividing the other, and together they carry a negative index, you reciprocate the numbers and the index becomes positive. That is what we did. Then we went to a fractional index. Fractional index, simply, we said there that when you have a number that has a fraction as the exponent, is the same as taking the root of the denominator all together carrying the exponent, which is the numerator, or carrying the numerator of the fractional exponent there as the exponent together. And we did examples to support that. In my next lesson, we will be using these laws to work real-time indices questions. So don't be too hard on yourself when you take these 8 laws and it's like you are not able to remember them. Don't worry, just take note of them. In the next lesson, we'll be doing calculations where we'll be reminding ourselves of each of the laws one by one, and that is where the understanding comes. So I want to use this opportunity to thank you so much for making time with me in my study room. I hope to see you another time. Please subscribe if you haven't done that. Subscribe to my channel, Mr. Chu Study Room, for more videos anytime I upload them. I encourage you to share with your friends as well so that they can all enjoy. And send me comments about how the lessons are, if you are getting them, if you have any challenge. But before I leave, there are some questions that will be displayed. Please take your time, pause the video and work them out to sharpen your understanding of this. Thank you very much and see you again. Bye bye.